to ensure the second stage ignition, and a TVC system. The first and second stages are both important to the structural integrity of the missile. To ensure that the stages maintain a maximal strength-to-weight ratio, both stages are reinforced by a carbon fiber reinforced polymer hull. 30. The second and third stage sections are connected by an integrated equipment forward/adapter section, S. The equipment forward/adapter section is modified to be shorter and more compact than the C4S adapter section. 29. The D5S equipment section contains critical guidance and flight control avionics, such as the Mk6 navigation system. The equipment section also contains the third stage TVC system, ordnance for ejecting from the second stage motor, and the MIRV platform. The nose fairing shields the payload and third stage motor. Mounted within the nose cap, above the nose fairing, is an extendable aerospike. 32. This aerospike effectively decreases drag by 50%. The third stage hull is also reinforced by carbon fiber and Kevlar. 30. The Trident II is the first missile of the U.S. Navy's Fleet Ballistic Missile Program to incorporate a 3D-printed component. 33. While Lockheed Martin is the prime contractor, a variety of corporations work on the Trident II. For example, in October 2020, Boeing was contracted for maintenance, rebuilding and technical services for Trident II navigation subsystem. 34, and Northrop Grumman was contracted for engineering support and integration for the Trident II and relevant submarines at sites and shipyards from Sunnyvale, California and Bangor, Washington, to Kings Bay, Georgia, and Cape Canaveral, Florida, among other locales. 34. Piraten was contracted for program support services on the Trident II reentry subsystem. 35. And Systems Planning and Analysis Incorporated was contracted for Trident II technical services, program support, assessments, special studies, and systems engineering. 34. Sequence of operation. U.S. Navy test firing 2 Trident II D5 UGM-133 missiles in the Atlantic Missile Range, June 2014. DASO 25 SSBN 736, during a demonstration and shakedown operation. Before the launch sequence is initiated, the onboard Mark 6 navigation system is activated. The specified mission trajectory is loaded onto the flight computer. 36. Once the launch command is given, a steam generator system is activated, igniting a fixed solid grain small rocket motor. 37. The exhaust is fed into cooling water, causing expanding gas within the launch tube to force the missile upward and out of the submarine. 37. Within seconds, the missile breaches the surface of water and the first stage thrust vectoring control, TVC, subsystem ignites. This enables hydraulic actuators attached to first stage nozzle. Soon after, the first stage motor ignites and burns for approximately 65 seconds until the fuel is expended. In addition, an aerospike atop the missile deploys hotly after first stage ignition to shape airflow. When the first stage motor ceases operation, the second stage TVC subsystem ignites. The first stage motor is then ejected by ordnance within the interstage casing. 38, 39. Once the first stage is cleared, the second stage motor ignites and burns for approximately 65 seconds. The nose fairing is then jettisoned, separating from the missile. When the nose fairing is clear of the missile, the third stage TVC subsystem ignites, and ordnance separates the second stage motor. The third stage motor then ignites, pushing the equipment section the remaining distance, approximate 40 seconds, of the flight. When third stage motor reaches the targeted area, the post-boost control system, PBCS, ignites, and the third stage motor is ejected. The astro-inertial guidance uses star positioning to fine-tune the accuracy of the inertial guidance system after launch. As the accuracy of a missile is dependent upon the guidance system knowing the exact position of the missile at any given moment during its flight, the fact that stars are a fixed reference point from which to calculate that position makes this a potentially very effective means of improving accuracy. In the Trident system, this was achieved by a single camera that was trained to spot just one star in its expected position. If it was not quite aligned to where it should be, it would indicate that the inertial system was not precisely on target and a correction would be made. 40. The equipment section, with the MRV, then aims the reentry vehicles, RV, towards the Earth. The payload is then released from the MRV platform. To prevent the PBCS correction or thrust from interfering with the RV when released, the equipment section initiates the plume avoidance maneuver, PAM. If the RV will be disrupted by the PBCS nozzle's thrust, the nearest nozzle will shut off until the RV is away from the MIRV. The PAM is used only when a nozzle's plume will disrupt the area near an RV. The PAM is a specialized design feature added to the Trident II to increase accuracy. 38. Warheads. In U.S. service, Trident II can be loaded with up to 8 Mk5 RVs with 475 KTW88 warheads, up to 14 Mk4 RVs with 90 KTW76-1 warheads, and up to 14 Mk4 RVs with 57 KTW76-2 warheads. In practice, each missile on average carries 4 warheads due to the warhead limitations placed by the New START Treaty. 41. The system previously carried the Mk4RV with a 100 KTW76-0 warhead, but beginning in September 2008 W76-0S were converted to W76-1S. This process was completed by December 2018. 42. Conversion from the W76-0 to W76-1 involved fitting the warheads with a new RV, the Mk4O, replacing age-limited components and fitting the warhead with a new MC4700 arming, fusing and firing, AF&F, system. The MC4700 AF&F system, dubbed the Super Fuse, significantly improves warhead kill probabilities against ardent targets such as silos or bunkers. The W76-2 is also fitted with the Mk4 RV and MC4700 fuse. 43. 44. In the National Nuclear Security Administration's 2021 budget request, the agency requested $53 million to begin development of a new W-93 warhead for use on Trident II and $32 million to begin development of a new Mk7 RV. If approved, the W-93 will be the first new nuclear weapon system to receive a Type A designation since the end of the Cold War. It is unclear if the W-93 will replace the W-76-1, the W-88 or both warheads. 45. In UK usage, Trident II missiles are equipped with a warhead called Holbrook 46, and have a maximum yield of 100 KT. 47. The UK government insists the warhead is a British design, but analysts believe that it is largely based on the US W-76 design. 46. 48. In 2011 it was reported that British warheads would receive its new Mk4AM reentry vehicles and some or all of the other upgrades that US W-76 warheads were receiving in their W-76-1 life extension program. 49. Some reports suggested that British warheads will receive the same arming, fusing and firing system, AF&F, as the US W-76-1. 50. Under a 1958 agreement, the US supplies the UK with blueprints of its own warhead designs, but the design, manufacture and maintenance of UK warheads are purely a UK responsibility. OR is currently developing a new warhead to replace the existing Holbrook warhead, with deployment expected in the 2030 S.46. Additional specifications. Range. Exact is classified full load, (7,600 km, 4,700 mi, 51. Reduced load, (12,000 km, 7,500 mi, 51. Guidance system. The Mk6 Astra Inertial Guidance Navigation System. Inertial guidance is most favored for the initial guidance and re-entry vehicles of strategic missiles, because it has no external signal and cannot be jammed. 52. SEP requirement, and LT 90 meters, 300 feet. 53. Information from flight tests is classified. Mk5RV, 175 kilograms each, offloading effects on D5 range, 51, Mk5 of throw weight, kilogram, D5 range, kilometer, increase in range, percent, 82,700, 54, 7,593 nominal. 72,532,278,962,3,519,111,205,108,35,10,5,195,231,825,113,482,001,115,192,78. Operators. Map with UGM-133 operators in blue. USS Kentucky. USS Kentucky, an Ohio-class submarine of the U.S. Navy. HMS Vigilant. HMS Vigilant, a Vanguard-class submarine of the Royal Navy. Columbia class. Dreadnought class. Artists' impressions of Columbia class, left, and Dreadnought class, right. The Royal Navy operates its missiles from a shared pool, together with the Atlantic Squadron of the U.S. Navy. Ohio-class SSBNs at Kings Bay, Georgia. The pool is commingled and missiles are selected at random for loading onto either nation submarines. 55. 23. Trident II missile submarines. United States Navy Ohio-class submarine. Royal Navy Vanguard-class submarine Vanguard. Henry M. Jackson. Alabama. Alaska. Nevada. Tennessee. Pennsylvania. West Virginia. Kentucky. Maryland. Nebraska. Rhode Island. Maine. Wyoming. Louisiana. Columbia-class submarine, planned, District of Columbia. Wisconsin. Victorious. Vigilant. Vengeance. Dreadnought-class submarine, planned, Dreadnought. Valiant. Warspite. King George VI. See also. JL2. Pukuk-Song 1. M45, missile. M51, missile. R29 RMU Sineva. R29 RMU Tulane. R39 Riff. RSM 56 Pulava.